Okay, so we're on this card here, and I'm finishing off the slides. So where I got to the last day was talking about the use of caching in our React app. And the problem here is our React app has to manage data. And there's two types of data, we said, client-side data and client state or client data and server data. And it's the server data that we're interested in, or the server state. In other words, the data that we retrieve from Tmdb in our case, but whatever the backend is, we're going to store that more than likely locally within the browser. And what we want to try and avoid is if our app needs some server-side data or server state, and it already has that data from an earlier retrieval, then clearly it wouldn't make sense to ask the backend for it again, because that's extra network traffic and it delays the rendering of our page. The only caveat to that, though, is we do have to be careful if the nature of that data is such that it is changing very frequently. Then there's a kind of a decision that needs to be made. Is the data that we have previously retrieved, is that up to date enough, or is it potentially stale? I'm not getting into that necessarily. Well, what we tend to do is any data that we retrieve from the backend, we give it a time to live value. And then if that expires, then that's a way of indicating that the data is potentially stale. But of course, you have to compute what is a meaningful time to live value for each data source that you're getting from the backend. Now, for our TMDB stuff, all the data is pretty stable. Once we retrieve it, then that data is not going to change, certainly for the duration of a user session in the browser. It'll change maybe from week to week, all right, but so the time to live didn't play a big role. So what we're saying is that the server state data, we need to store that in the browser. Now, we could manage all of that ourselves, and we could build in some logic, which every time we needed some server-side data, we looked in our local storage to see, do we have it already? If we don't, get it and put it in there and give it back to the UI. If we do, then just give it to the UI. I suppose it wouldn't be that big a deal, but there are libraries there that do it for us, and we tend to generically refer to those libraries as caching libraries. And we use this as our little sample app the last day. So I'm just going to kind of skip on from there now. We know what the workings of this app was all about. So if I pick up the story, let's say, okay, let's say here, even though I covered these the last day. So what we now have within the browser is we have our React code, which is Maria here. And let's say this is a particular component. We have our caching functionality, which is going to be implemented by a third-party library. And the way it works is our component asks the cache, do you have a particular piece of data? And it identifies the piece of data by means of a key. So a simple thing might be a movie ID might be a key, or just discover. Remember, one of the endpoints, the TMDB endpoints that we used was the discover endpoint that gave us 20 movies. So discover would be another key. We ask the cache, do you have an entry corresponding to this key? And if it doesn't, it gets it from the back end, stores it eventually when it returns back, stores it within its own data management, when it's within its own cache, and then it gives it back to your component. And then later on, the component might ask the cache for the exact same piece of data, but now it has it locally, so it just gives it back. So this communication here is synchronous, whereas the communication here is asynchronous, as in there's a delay between this and this. A cache is a data store And the structure of that data store is, it is a key value data store. So each entry in a cache, each entry consists of a key and a value. Oh yeah, let's go back. So the technical term for what happens here is we say there's a cache miss. Cache miss happens here because there's no entry in the cache, whereas we have a cache hit here. And then there's some other kind of terminology around caching, which I'm detailing here. And I did talk my way through those the last day. Now, in relation to React, there is a really, really nice library called React Query that implements caching for us. And the way the interface for this React Query library is a series of hooks. So it's kind of bang up to date, really. I'm not too sure. I'm sure there was earlier versions of the React Query library that didn't use hooks, because as we know, hooks only came into React around, what is it, 2018, I think. So either way, our interface to this React Query library is by means of hooks. And the predominant hook that we use is this one here, React Query. Sorry, use query. And the arguments that you pass to this hook is you give it the key of the entry that you're interested in. So this might be a movie ID, or this might be the discover string. And you also give it a function. And the function is what the React Query library will use to retrieve the data from the backend. And we know what that function kind of looks like. You know, it has a fetch statement in it. So we could essentially, we've seen that kind of code before. And what the hook returns back to us is all of these things here. And these, which we're just doing destructuring here, these allow us to use within our React code to make kind of decisions. So for example, this here is going to be a Boolean, and that will tell us whether the React Query library is waiting for a response back from Tmdb. This one here tells us if we actually got an error response back from Tmdb. This is the important one, I suppose. This is the one that's going to contain the actual data, whether that data came from directly within the cache because it already had it, or it came from, ultimately came from Tmdb and it put it into the cache and then it gave it back to us. So really what we finished up doing is we finished up removing any use state and use effect hooks that we have used up to now. Certainly the use state hooks that were related to managing data that we got from Tmdb, and the use effect hooks, the corresponding or the associated use effect hooks, they can now be taken out and we can replace them with this one nice simple statement here. Internally within this, it is using use state and use effect, but we needn't worry about that. So in fact, this makes our code cleaner, although there's a little bit of extra kind of mental stuff that we have to work out in our head in terms of understanding what's going on behind the scenes, i.e. this idea of a cache. What am I saying down here? Cache. Oh yeah, to re-render. Well, yeah, okay. So we still get this kind of re-rendering, because if one of our components executes this piece of this statement here, and it turns out the cache does not have a match for the particular key in it, then we don't want our component to freeze. So what our component code will do is it will immediately check this thing here. And if that evaluates to true, which means our React query is waiting for a response back from Tmdb, then if that's true, then we should render something onto the screen. Eventually the data will come back and this will become false. And then our logic then there's a re-rendering will actually happen automatically. And because use query will force the re-rendering to happen. And then this will become false, as I said, and our logic within our component will display the actual data that came back. And hopefully you saw that in the sample app that I gave you accompanying this set of slides. Now, an important part of these arguments here is the key. What can the key be? And I'm just saying here that the key can really be anything that is serializable. So you've got a lot of flexibility, as it turns out. The React Query library gives you a lot of flexibility in terms of how you construct your keys. And so really, when I say anything that is serializable, a string is serializable, a primitive is any kind of primitive is serializable, an array is serializable, an object is serializable. But if you kind of read a little bit about React Query, quite a lot of times we use an array to document our key. And this is an example of a key that we actually do use in the, not only in the movies app that we're building up in the labs, but in the sample app that I gave you with this set of slides. And so the key is comprised of, it's an array that's made up of two elements, and you can interpret this yourself, right? It's just a string followed by an object. And it looks like maybe that might be the ID of a particular movie. Now, in the actual code, this would be a variable that gets its value from somewhere, maybe from a prop or something like that. But the point I'm trying to get across here is that this is actually a valid key for our cache. So the actual cache key will actually be that array and we can actually see that, I suppose, if I flip over to the sample app that I gave you 2 weeks ago, which I think I already have in here. Yeah, I think I started it there earlier on. I just collapse this first. So you remember this is the homepage, Maria, of our app, and here's our list of 20 movies from Tmdb. And if we click on one of them, then we get the details of that particular movie with very poor styling. In terms of our cache, we can actually look inside the cache. This is a really nice thing about React Query. It provides its own developer tools extension for us. So what I'm actually showing you here in the black part is the current contents of the cache. And if I just do a manual refresh of the home page, the way I can interpret this now is that there is one entry in my cache. The key is just a simple string called discover. And if I click on that on the right, if I click on it on the right, I get lots of information associated with the entry. In particular, I can see the actual data corresponding to that entry. Now, the discover key is the key that has as its value the 20 movies that we got back from Tmdb, these guys here. And that correlates with what I'm seeing here. Here are my 20 movies. And if I drill down, then, I get what I expect to get. That's actually my movie data structure. And if I go to one particular movie, go to the details page. Now there's a new entry in my cache. This is it here. And this is kind of very similar to the key construct that I showed you on the slides there a moment ago. I just arbitrarily came up with this. I could have called it M just for movie, followed by maybe just the ID itself rather than this object. But I guess this is a little bit more clear in terms of what it might be documenting for the developer now. Obviously, the user doesn't see this at all. And if I click on this entry, then I can see the actual data corresponding to it. So this dev tool that comes with React Query, I think is really, really nice because it really allows you to see exactly what is inside the cache, which only a developer would need to be concerned with. So let's see. Oh yeah. So okay, that's an example of a slightly more elaborate key. We know the second argument that we need to pass to use query is our function. And here I'm showing you an excerpt from the function. The function now is going to be responsible for retrieving the actual data from the backend if it currently doesn't have it in the cache. And all I'm trying to document here is this function, which you implement okay, but it expects one argument. Now, the use query hook will take care of instantiating this argument, or setting it up for you, and it will do it based on what key you've given it. So if you just follow the code here, right, the args argument, it's going to be an object, and one of the keys in it is query key. As I said, the React query library now is going to take care of instantiating this for you and populating the object for you. And one of the keys it puts into the object is a key in the terms of an object now, right? The key called query key, and that I'm just destructuring it here. That expression there is actually going to be equal to whatever you've put up here. And all I'm doing is I'm destructuring it. I'm essentially saying I'm not interested in the first part, I'm only interested in the second part. So ID part corresponds to this object here. And I'm doing some further destructuring here, because really what I want to get at is this value here. I want to get at that. And then I make my HTTP request to Tmdb with that particular movie ID. Of course, we know this function is only going to be executed if React Query has discovered it doesn't have this actual entry in the cache. Going to pause maybe, and let's see if we have any questions so far. No. In this slide, I'm just showing you kind of what I was talking about there a few moments ago, that the React Query comes with a really nice DevTools plugin. And I've kind of talked my way around that a few moments ago. So also what you can do with the DevTools plugin is you can actually make changes to the cache itself. Now, you won't really need to have to do that, but you can. These buttons over here allow you to make changes to the cache. So for example, the refresh button, what that does is, what you will do is you click on a particular cache entry. If you hit the refresh button, that will force, as I'm saying down here, it will force React Query to grab, to talk to the backend and get an updated value for the particular key. So you can actually, do that from here, and you would only do that during development. This one invalidates that. What that does is it kind of tags the entry as being stale. And if an entry is tagged as being stale kind of means its time to live has expired. By tagging an entry as being stale, what that will result in is the next time the React app needs that particular piece of data, then React Query will talk to the backend to get it. It won't do it immediately. It'll only do it once it's required by your front end. Whereas when you click the refresh, you're actually telling the React Query library to talk to the backend straight away and get an update. The other two, this one is obvious, just gets rid of the entry from the cache. This one is only relevant if the data that you're putting into the cache is actually data that you can update from within the React app itself. And that does complicate things, because if your React app is able to update the data that is being stored in the cache, then not only do you need to update the cache, but you also need to update the backend. And that does complicate things, but it doesn't arise in the case of our movies app, because we're only ever reading data. So you won't really need to worry about those. I think this will be kind of interesting when you start working with the assignment associated with this part of the module. And that's about it really in relation to what's generally referred to as state management, state being data. And as we said at the outset, there's two parts to data, client-side data and server-side data. Really what I've been talking about predominantly up to now is server-side data. The client side is straightforward enough. And yeah, two types of data. Caching is great for managing server-side data, managing it within the client, within the browser. And our React query is, I think it's probably the only one that I've come across that, well, sorry, there is one other one as well. There is another library that has the same kind of role as React query, but I would argue that this is the better of the two and certainly the nicer one to work with. Right, if you happen to have started the lab for this week, I'm bringing in the React query library pretty much to everywhere I would have been talking to Tmdb. So that's getting my 20 movies, getting the movie details, getting the reviews, getting the genres, the list of genres, and you'll see as you work your way through the lab that we're using it pretty much everywhere. I may not have actually used it in relation to the reviews, but it would be straightforward enough to bring it in there as well. Any questions, I wonder? No. The last topic, which is really an odd thing to be talking about at the very end of what's been fairly heavy going now, admittedly, is good old login, logout. How do I implement login, logout, or authentication in a React app? Sounds like a fairly boring topic to be talking about, and from a user feature perspective, it is, but the implementation of it is quite tricky, as it turns out. So we know what authentication is. Another way of kind of stating what we want to achieve is to have a mix of protected or private routes as well as public routes. Public routes within our app are routes that anybody can navigate to. Private or protected ones are only accessible if you are already authenticated. Or even features, maybe features within the app as well might be authenticated. So for example, in order to tag a movie as being one of your favorites, you can only do that if you first authenticate. So you can have it at the feature level as well as at the kind of the route level or page level. Now, there's a sample app accompanying this set of slides, and it goes way back to the routing samples that I gave you, I don't know how many weeks ago. So if I bring those just back in to remind you. I think they're here, yeah. So it is sample 9 in this set of samples. I don't think I need to run it because the screenshots here, I'll just explain what the way this little mini app works. So I've got a series of navigation headers, Maria, at the top of my page, and anybody can click on the home page and the home page will render. Anybody can click on the public hyperlink and that page will render. However, if you click on either one of these navigation links, then you are forced to log in. And so if I did click on the inbox, it will actually redirect me to the login page. Now, you know, I've left out the username, password stuff here. We don't need to worry about that. So ordinarily you would have username, password. You click on login, And the way I'd like my app to work is when I click on login, and assuming my username password combination are okay, then it will take me directly to the page that I want to go to. An easier implementation would be, I click on inbox, I get the login page, I fill in my username passwords, click on login, and then it just sends me back to the home page. And then I can click on inbox again, and now I can go into the inbox page. But it would be a nicer user experience if somehow the app remembered where I wanted to go to when it forced me to log in. When I eventually, what we'll also notice is once you log in, you now have a sign out button option up here, whereas when you're not logged in, you have the option of going directly to the login page yourself. Without being redirected, if you like, once you try to access these. So these are my two private or protected routes, whereas these are public routes, we would say. So that's fairly standard kind of behavior related to authentication. And we'd like to implement that. Okay, so I'll just skip over all of that. Yeah, so I've also decided once the user clicks sign out explicitly, then by default they're just taken back to the home page. That's fairly obvious, I guess, and fairly common. So this notion of protected or private routes, as it turns out, you might think it's something that would come with the React Router library, but it doesn't. We have to implement it ourselves. And okay, so we have to come up with a kind of a, what we call a custom implementation. And if you Google around, you will find a number of implementations, but one that I came across, and in fact, I think if you look at the React Router docs themselves, they have it as a sample. They have it as a recommended kind of implementation of implementing protected routes. So it probably came from there originally. I came across it in just an article or blog that I read some time ago, and I played around with it and changed it a little bit. So we need a custom solution to this problem of implementing protected routes. And I guess we'd like our solution to be consistent with the whole React kind of programming model. So we'd like it to be declarative, clear, obviously, all coding should be clear, but declarative is the key thing. We'd like a declarative way of expressing a route as being a protected route. So maybe wouldn't it be great if we could implement something like this? So this might be routing configuration for an app, and in our case, it's the little sample app that I'm giving you the code for. And so we've seen this before. So the way we can interpret this routing configuration is to say, well, that's a public route, that's a public route, that's a public route, and these two are private routes. Now, there is no component called private route. We have to implement it ourselves, but it has the same kind of signature as the other ones. And so again, it's kind of consistent with the way React Router implements routes, path prop and a component prop, path prop and a component prop. And we'd like it to work exactly as before. So if the browser's URL changes to this, then this component is mounted. Of course, behind the scenes, what's going to actually have to happen is if the browser's URL changes to this, then our app needs to work out, well, has this person logged in or not? If they have, that's fine. I can mount this component and away they go. If it hasn't, then I've got to redirect them to the login page and let them enter their username and password. Then when they click the submit button, I validate that. And if all of that is okay, then I can mount this component. So all of that logic that I've talked my way through, we've got to implement that somehow behind this declarative statement here. So the elements that will make up our overall implementation, we're actually going to use a React context. because knowing whether somebody is currently logged in or not is probably information that a number of pages and components across our app would need to know. Okay, so in other words, it's kind of global data or global information. And whenever we say global information in React, we think React context. So we're going to have a React context to essentially store the credentials of the currently logged in user and whether somebody is logged in or not. They're kind of they're related, obviously. Secondly, we're going to have lots of programmatic navigation going on. We know we redirect the user to the login page if they're not logged in. We redirect them back to the home page once they sign out. We redirect them to the page, to the page they want to go to when we force them to log in, all that kind of stuff. And we know how programmatic navigation, we've seen how to implement that. Part 3 then is what I was alluding to there a while ago. This is kind of an optional extra, but it's certainly from a user experience, it's a nicer experience in that we'd like our app to remember where the user was trying to get to when we forced them to log in. And I'm just calling that the kind of remember user's intent. Okay, so sorry, so there are the 3 things that we need to include in our implementation solution to this whole problem. So if we take them kind of one by one-ish anyway, certainly we can start here. This is what I'm calling my auth context. So it's a standalone context. And remember, a React app can have many contexts. So in our movies app, we would have a movies context and we might have an auth context as well. But if we look at the detail then of this context, well, it's going to have some state. It's going to store the username and password. Maybe password mightn't be a great idea, but I've left it in anyway. So it's going to store the current username and password combination as state. This looks like a function. Now I've obviously cut a lot of corners here, but this is a function presumably that will be executed when the user fills in the login form with their username and password details. So these will be passed into this function. I do some sort of validation, which I've obviously left out because I'm not interested in that. And if everything is okay, then I change the state up here, or here, sorry, I change the state. And we know what changing the state will cause re-rendering. I also have this convenience Boolean here, which is going to be true or false. And you can see how I'm deciding what the value of it is. I'm essentially checking to see is user.username, that would be user corresponds to here, and user.username corresponds to whatever value would be here. So if that expression is equal to null, which means would mean somebody is not logged in, then is authenticated will be false. Otherwise, it's going to be true. Yeah. So that's just a convenient Boolean. This here looks like a function that would be invoked when the user clicks the sign out button, and I'm just resetting my state back to null and null again. And we've got the usual stuff here, right? We know what a context is all about now. So we're making these things available to the rest of our app as the values within our context. And I've defined my context up here, of course, as before. So that's all fairly familiar, I hope. This is the interesting part now. So this is the component that I need to implement. And we've already seen how it would be used within my routing configuration. So here is the implementation of it. Now, if you kind of ignore some of the detail for a moment, essentially what this component will do is it will either return a normal root component or it will return a redirect component. So if you like, anywhere in my routing configuration, I have one of these. What will happen at runtime dynamically is it will be replaced by either a normal route component or replaced by a redirect component. It would be replaced by a normal route component if the current user has authenticated. It would be replaced by a redirect component if the user hasn't authenticated. And that will happen dynamically and may actually happen multiple times. Like the user comes along, they're not authenticated, they try to access a particular protected route. This is now going to be substituted up here. Then they authenticate, and later on they come and they want to access the same page. Now this is going to be replaced by a route component, Then let's say stupidly they log out again and they come along and they try and access /inbox. Now private route is going to be replaced by redirect, and on it goes. Okay, so essentially this component at runtime is going to be replaced by this or this. Now the rest of what's going on here then is concerned with kind of configuring all the stuff that's going on over here and the stuff that's going on here, configuring these two components. What am I doing? I'm bringing in my context, my auth context, and what I'm doing here is I'm taking the props that are passed in here. So we can see two of the props are these ones here, path and component. There may be other props though, default props that are provided by the React router itself and React potentially. So I'm taking the props and I'm doing some destructuring. Specifically, I'm taking the component prop within this, which corresponds to here, and this value here. I'm taking that and I'm declaring a new variable called component with a capital C. So that new variable is going to be assigned whatever value would be over here. And the fancy stuff that's going on here, this is my spread operator. This is quite heavy code now, I admit, but already the way you can interpret what's going on here is I'm declaring a new variable called rest. And what it will contain is all of the other entries in my props object except this one here, i.e. this will contain the rest of the props that were passed into this component. So path would obviously be one of them, but there might be others as well. So that's one line of code, but there's a lot going on there. So essentially I've got two variables now. I've got a variable called component with a capital C, and I've got a variable called rest. And then I'm using them down here. And so I'm essentially checking here, is there somebody currently authenticated? So if this all evaluates to true, i.e. there is somebody currently authenticated, then you should return a route. And here I'm configuring the route. I'm using rest, which I have defined from up here, and I'm just spreading it out to its individual key value pairs. And I'm using the alternative form of the route. There are two forms of route. One is where it takes a path and a component. The other form of the route is where it takes a path and the render prop. So we've seen this before, and my render prop in this case takes a function. It always takes a function, and it is returning an instance of component with the capital C. So for this particular example here, the component would be inbox, because that's the component that I want to have mounted, or that's the page, if you like, that I want to have mounted. And all the other stuff here then is kind of stuff that we've seen before. You could take a lot of this as boilerplate, really. You could literally cut and paste all of this, and it's all just going to work. But I suppose I do need to explain it to a certain degree. Props here, kind of the props here is the props that was passed in here, and that props is close enough. It's kind of taken care of by a React router. We needn't worry about it. It will contain a lot of props that are actually defined by a React router, many of which we don't care about. The the redirect case is going to be active if this expression up here is not the case. In other words, somebody is not authenticated. And the redirect takes a top prop, which we've seen before. The top prop can either be assigned a string, which would be the path name that we want our app to be directed to, or it can take an object, and we're using the latter form here, where the object has to have a key called path name. And lo and behold, we are redirecting them to /login. That's fine. And we know the way the redirect works. This is going to force the browser's URL to change to that, and that triggers the React router to make a routing decision. In other words, it's going to consult its routing configuration. And if I might just go back for a second, we have a normal route entry for /login, which says load the login page component. So that's what's going on there. What's happening here is I need to pass to the login page the URL that the user was trying to get to. Now, in this example, the URL that the person was trying to get to was this one here. And the way I'm accessing that is by using a location prop that is automatically provided by React Router. We needn't worry about it. It's just there. And I'm exploding here the details of it. And we can see that one of the key parts of it is it actually has a key called path name, which has the URL that the user was trying to get to. So what I'm doing here is this is how I'm actually managing to pass to the login page the URL that the user was trying to get to. So I did say at the start, it isn't straightforward. Here's my login page. And essentially what it's going to do is it's checking to see, again, if we can get to the core of it, the core of it is here. It's checking to see, is there somebody currently logged in or not? Now, stupidly, a user might actually, if you imagine a user has authenticated and they, for whatever reason, they change the browser's URL to /login, they just go directly back into the login page themselves, even though they authenticated previously. So that could arise. And we need to be able to take care of that in our login page. So we always have to check to see, is there somebody currently logged in or not? And so here we're saying, well, if they are logged in, then redirect them to where they want to go to. I wonder would that actually handle it? No, I'd have to think about that actually. Let's ignore that. Let's ignore that odd kind of case. Let's take the normal cases where we're sent to this login page when the user is not authenticated or is authenticated. Okay, so we check to see, are they authenticated or not? If they've been sent to the login page by our app, then that means they're not authenticated. So it's going to skip over that, and it's just going to render my login page. Eventually, the user fills out the details and they click the submit button. That triggers my function up here. And I talk to the context. I invoke that function that we had in the context that takes the username and password, which I've just hard coded here because I don't have a login form. And this function does its thing, and maybe it evaluates that this combination is fine. So it changes the state above in the context, and I get a complete re-rendering, which means this whole thing re-renders. Now this expression here is true, and we redirect them to where they want to go to. And the from here is computed up here. And essentially we're reusing the props.location.state that we set up back here for ourselves. To be honest, you could take a lot of this as boilerplate code and just lift it, and it's all going to work for you anyway. All you really need to do as a developer is put these entries into your routing configuration. Decide what pages you want to have as private and put the corresponding entries into your routing configuration. Take the code that I'm giving you here, put that into your Movies app, and you will find that it all works as you would anticipate it to work. The coding is quite tricky, what's going on here. I'm also kind of conscious now that my time is slightly running out on me as well. Yeah, so kind of what's going on here is I'm trying to find where do they want to go to. What's going on over here is to handle the case where the user went directly to the login page themselves rather than being redirected. And I've made the arbitrary decision that if a person goes directly to the login page themselves for the purpose of logging in, and they click the submit, then we don't know where they wanted to go to. So we just decide arbitrarily, let's send them back to the home page. In other words, let's change the browser's URL to this. The app will be redirected to that location, and based on our routing configuration, that will render the home page. That's kind of really what's going on here. That's taking care of the two possibilities. So this is executing during a re-rendering, and now this statement is true. So we redirect them to where they wanted to go to. So this here is either going to be determined from here, or it's going to be determined from here. Yeah, so that's you would, if you really want to understand in detail how that works, it would require you to revisit, and I suppose I expected to do that, but there's a lot of fancy kind of coding like this stuff here and all of this stuff going on down here and this stuff going on up here. That's quite tricky coding, but as I've kind of said or alluded to already, you could treat all of this as boilerplate, and all you need to do is take care of this stuff in your routing configuration. And I'm pretty confident that it will work for you if you decide to do that and bring it into your Movies app assignment, because authentication is one thing that I mentioned as a possible extension in the assignment. Now, that's the last slide. I've got a tiny few minutes left, not enough though, but critically, on Moodle, this time now, not on the website, we have published the specification for assignment 1 here. And here it is here. So that's predictable enough. We want you to extend the Movies app. That's the objective. Set that as the date and update. So lots of time, but time flies as it always does when you don't want it to. I can skip over all of that stuff. It's just standard, although this is extremely important, which I've alluded to already. You've got to have a Git log, and you've got to have a README in the repo that you submit to us. But I give you a very detailed template for the README, and you don't need that for now, but I will provide it closer to the hand update. And it's extremely important that you fill that out because that is your documentation, and we do use it for assessing. We use it extensively really when we are assessing your stuff. And then I provide a grading spectrum. Now, so there's what you need to do to get between 40 and 50. So what you need to do, essentially kind of what I'm saying here is that the additional code that you submit on top of the lab work, it'll be characterized by the fact that you will have new pages or views in your app, but they will be almost identical in structure and style to the pages that you developed in the app. So that could really mean that you have very little new components to write. You'll have new pages, all right, and you'll be getting different data from the backend, but you'll have very few new components, maybe 1 or 2, or 3 maybe components. So and then I'm fleshing it out a little bit here. So let's say roughly 3 new views or pages, roughly 3 new Tmdb endpoints. I do need to talk a little bit about Tmdb endpoints to you, but so far we have used 3 Tmdb endpoints, or maybe 4. We've used the Discover endpoint. We've used the endpoint that gives us the details on a particular movie. Now, it turns out that that movie's endpoint has lots of other options associated with it as well, which are significant. We've used the genre endpoint, and the list of reviews that we get for a movie, that's actually part of the movie's endpoint as well. So we've used about 4-ish endpoints. I'm suggesting you should maybe use roughly 2 or 3 more, and I'll talk a little bit about that. There may be some, if you have 1 or 2 new components, then there will be the opportunity to write 1 or 2 storybook stories for them. To get into this grade band, now we're talking about maybe you have in some of your new pages, or even the existing pages, you've developed some of your own components. Okay, so you're confident enough and competent enough to be able to do that and get them to work. So maybe the layout of 1 or 2 of your new pages is different from the layout that I've given you so far, or parts of the existing pages, you've added some new content to it, and obviously you would have to write the components to render that content. In terms of features then, so we're up to, you need to be using certainly more than 3 Tmdb endpoints, could be up to maybe around 5-ish or so. That may sound daunting, but it's not actually, as we'll see when we look at the Tmdb in a little bit more detail. By extensive data hyperlinking, where we have data hyperlinking at the moment is if you think of a movie card, we have a more info. The more info is essentially a data hyperlink that brings us on to another view, and the view is linked to whatever we clicked. Similarly, when we have a list of the review extracts, there was a more kind of link there as well, and we clicked on that and we got the actual full review. That's what I mean by data hyperlinks. Like in the movie card, I could have hyperlinked the movie title. That would be a better example of a data hyperlink. I'm actually hyperlinking a piece of data on the screen. Now, when you click on it, it brings you to a new view, and presumably the new view is related to whatever hyperlink you clicked. You know what hyperlinks are, but that's what I'm getting at here. Filtering and sorting. At the moment, if you think of the home page, or the page that shows 20 movies from the discovery endpoint, we can do filtering on the basis of title and genre. Maybe you could add in 1 or 2 other properties of movie and do filtering based on those. Also, we don't have any ability to sort the movies that are being displayed. Maybe you could add that either to the filtering card, or have a separate card that allows the user to do sorting. Both of these would require you to add state. So you need to understand the notion of state and changing state and re-rendering and all of that. I'm saying that you should be using caching everywhere, and you will have a lot of caching implemented from this week's lab. So it's a case of just taking that knowledge and applying it to anywhere else you're interacting with Tmdb. Obviously, in this bracket here, you will definitely have some of your own components. So you will definitely need to write storybooks. You will definitely need to write storybook stories for them. Here's what I was talking about a while ago: simple authentication. Literally take the code from that sample, routing sample that I was talking my way through there a while ago, bring that into your Movies app, and just decide for yourselves which particular pages and views and features you want to have as private. Now, the username passwords that the user is going to be entering, they're just going to be stored. You could have a static array with 4 or 5 different username password combinations, and that's how you do your validation. There's no backend involved here. So that's why I'm kind of describing it as being simple. To move on to this bracket here, you really have to read up on topics in order to, and then apply that knowledge to get into kind of this bracket. So that's why I'm calling it independent learner. Now, I'm very conscious of time now, and if people need to bail out then and go off to another lecture, that's fine. I might just continue on for a little while, and you can see the recording anyway yourselves afterwards. So don't worry if you have to leave before I finish. Searching would be a really nice thing. If you think of the homepage, we just get a list of movies. Okay, we can do filtering on them, but a more elaborate kind of search feature would be nice. The way I kind of envisage this is, supposing we had a separate view that was just a web form, and the web form allowed us to select various properties of a movie that we're interested in, or movies that we're interested in. So it's a standard form with a mixture of text fields, maybe drop-down menus, checkboxes, and all of those data entries are allowing us to specify the characteristics of movies that we're interested in. And when we submit that form, then we get back a page that lists movies that have those characteristics. So it's your typical kind of search feature. That would be a really nice feature to add in. Pagination. The home page at the moment displays 20 movies, but if I bring in the movies app that we have, or that you will have by the end of this week, which is, let's see if I get my copy of it. That didn't come in, I think. In fact, I can, oh no, oh, it did come in, sorry. So here's get movies, and if you look at the URL, and if you go right to the end of the URL, you see this part here. We're specifying a page number of 1. Sorry, yeah, a page number of 1. Now I've hard-coded that. It turns out that this actual URL is paginated. So you can have any value between 1 and 20, I think. Or is it 200? I can't remember. You have to look up the documentation. We've hard-coded it to 1, but wouldn't it be nice if in the home page, that is the page that discovers movies from the discovery endpoint, we had that view was paginated. So we had our pagination links at the bottom, and we know what pagination looks like. You know, you have 1, 2, 3, 4, 5, and all that at the bottom. And by clicking any one of the links in our pagination at the bottom, that will change this value here to whatever the user has clicked on. And that's going to send a request to Tmdb, and it's now going to send us back 20 different movies. It always returns 20 movies, but the page number that you give it dictates which 20 movies it returns. And I think there are 2,000 movies in total that are supported by the discovery endpoint. When we say page number 1, then it gives us movie 1 to 20. If we change the page number to 2, it will give us the movies 21 to 31, and so on. So actually having pagination support built into our homepage and any other Tmdb endpoints that supports pagination, although you need to really only get it working for 1, that would be sufficient. Because if you've got it working for 1, then you've shown that you're able to do it. So that's would be a nice feature to have, and that's what I'm talking about there. Sorry, that's what I'm talking about. Beg your pardon. That's what I'm talking about here. Pagination. The responsive UI. Again, if you, I should really bring up. Let's start this guy. Right. Back to my home page. Now, in terms of responsiveness, I've already given you one example of how I've implemented it, and it's just supported by the Material UI library. And so if you remember, I think it was in the earlier labs. Maybe it's in this week's one, otherwise it's in one of the earlier labs. But here I've got my navigation links just as ordinary links, but if I reduce the size of my viewport size, as I call it, it changes to a drop-down menu. Okay. Now the way I implemented that was that is an example of responsiveness, that the UI has actually changed based on the size of the viewport. And if you look at the implementation for the particular component that implements the header, I've shown you how I managed to do that. It's essentially using what are they called? Media queries in the language of the web. So, but I have shown you how to implement it, and the implementation that I've shown you can be used anywhere. So, for example, another case where you might use responsiveness is, and this is only one example, maybe in this view here, if the viewport size goes very small, maybe these images here should just disappear because they're taking up unnecessary space. That would be just one other example of responsiveness. And maybe you could see other opportunities as well. Now, what you don't need to do is have responsiveness all over your app. Just implement it in maybe 2 other places. And you will mention where you implemented it in the README. That's why the README is so important. So back to my spec. That's the responsiveness idea, pagination I've talked about. There may be other Material UI components that I haven't used. There certainly are lots of them. You may get an opportunity to use 1 or 2 other Material UI components that I haven't used, and that will be reflected in the UI itself, because that's what Material is all about. So you could have just this quick scan through some of the documentation and look at some other UI components that it supports and see an opportunity to use them. And so that's how you would satisfy that requirement there. Third-party authentication, whereas up here, I said you could just have simple authentication, i.e. there's no real backend involved in it. Third-party authentication is more robust. Now, some of you may or may not have heard of Firebase. Firebase is it's many things really, but what it does include is authentication support. It's a web service, okay, that just provides authentication support, so it can store your username, password credentials, and other data, user profile data as well if you want to. You don't need to get into that though. So as I said, if you haven't heard of Firebase, then it's something you would have to read up on, obviously, but you may have heard of it, and so you've got a notion of what it's about. There are lots and lots of articles showing you how to use Firebase with a React app, or you could use something alternative to Firebase. There may be another third-party authentication service that you're aware of, and bring that into React, into your Movies app. Clearly, you would, ideally you would find an article on the web that has already shown you how to do it, and you follow that and the usual story. And there's always other. So if there's some other feature, be it a feature or some technical side technology that you want to use with your Movies app, then we're always open to that. Or maybe there's a little part of the React library itself, which I haven't covered, and you can bring that into the Movies app. That would be great as well. But you probably have to have come across that already, maybe. You may not have the time now to start scanning around looking for other aspects of React, but other can cover anything really. It's up to you. I kind of talked my way through those. At the top end then, well, if you've got a really almost production quality, but by the way, we're really only looking for a prototype standard here. We're not looking for squeaky clean user experience and squeaky clean styling. A prototype is more than sufficient. But I suppose if you're up at this kind of grade band, then you're the type of person that, you have very clever user features. And there's lots of opportunities to, to think about what might be useful user features for our Movies fan app. Or it turns out that, the way we've been using TMDB up to now, we've only been reading data or getting data from TMDB, but you can actually store data in TMDB as well. And an example of that would be our list of favorite movies. We're just storing our list of favorites in the browser. And so clearly, once we shut down the browser and restarted, we've lost them, unless you put them into local storage, but that's not very sophisticated. What you can actually do is you can post your favorites list to TMDB. So TMDB has this thing just called lists. And a list can be anything. So you might have your favorites lists, you might have your top 10 of all time lists, or your favorite actors, blah, blah. A list can be anything. You define what your lists are and you decide what goes into a list. So TMDB supports that, and you would really have to look at TMDB documentation as to how you create these lists and populate them. And in order to do that, it involves using tokens and sessions. It's not impossible by any means, but you'd have to read around it. Now, TMDB is clearly at the core of everything that's going on here. So we do need to spend some time looking at and understanding the TMDB API itself. And that's what I'm kind of outlining here. So at the very top, I've got a link to the TMDB documentation, and let's click on that. I'm just going to close off some pages now because I've got too much open here. I think I can get rid of that now and that. Okay, so what I'm documenting here is some of the endpoints that TMDB provides. So we're very familiar with the discovery endpoint. That's the one that's used by our homepage. So let's see the discovery endpoint over in the TMDB documentation. And it's down here. Here it is. And it's straightforward enough. It says the discovery endpoint, you can get movies, you can actually get TV series stuff as well. So that might be another area that you might be interested in. But let's just stick with the get movies. And if I click on that, which I think it's already there. Yeah. So here's how we talk to the discovery endpoint to get movies. And this is what we've been using all along. If you look at the API calls that we're making. So get discover / movies, that will return 20 movies to us. But if we scan down a little bit, it turns out that okay, you need to authenticate yourself when you're using that endpoint, but we know how to do that. That's using the API key in our query request. And here's telling us that you can have a query string associated with any request that you send to this endpoint. And we're actually using that already, whether you've looked at the detail or not. So if I go into here, here's my request to the discovery endpoint. And here's my query string all the way across here. Now I've hard-coded the query string in this example. Well, okay, this part here isn't hard-coded, but the rest of the query string is hard-coded. So I've got a query string is made up of key value pairs, and I've hard-coded some of the key value pairs. And I've already talked about the page key value pair in the query string. But it turns out that this query string has, I think, 30 or 31 different options that you can include in it. And it's documenting them here. And you can see here, look, there is view all 31. So what this query string allows us to do is to be more specific about the characteristics of the 20 movies that we want it to return to us. And, you know, these look fairly familiar kind of characteristics like, let's see, my page is okay. Release dates, when was the movie released? Maybe we're only interested in movies after a certain date or before a certain date. Type, what year was it released? Movies have popularity kind of counts or votes associated with them. So maybe you're only interested in movies that have a count greater than a particular value or not, etc., etc. Okay, you can look down through all of these criteria. Now, you certainly won't need to cover all 31 of them. You can take a small subset, maybe 4 or 5 or 6. And what would be nice is to have a web form that allows the user to specify or to specify values for a subset of these query string parameters. And then when the user fills out that web form and clicks submit, your code will dynamically construct the query string and tag that constructed query string onto the end of the actual URL itself. That's what I mean by a search feature now, which is up in the kind of 70 to 90 grade brand. Okay, so that's the discovery endpoint. So there's lots of power there that we haven't been using at all in our app. We've just said, give me the 20 movies associated with page 1, which tend to be the 20 kind of more recent movies from its 2000 list of Discover movies that it stores internally. That's the discovery endpoint. And here I'm talking about this kind of search feature that I've talked about already. The movies endpoint, well, it has lots of kind of sub endpoints associated with it. What we have used is we've used the movie endpoints to get details on a movie. We've also used the endpoint to get the reviews for a movie, but you've got these other ones as well. You can get the full cast and crew associated with that movie. You can get a list of similar movies to that movie. So a nice feature might be in our movies detail page, there might be a simple link that says similar movies. When you click on that, it either brings you to a new page or it shows you a table at the bottom of the movies detail page listing the names of similar movies. That list of movies could be hyperlinked, and if you click on them, then it brings you into the movies detail page again, but now you're looking at the details of that particular similar movie. Recommended movies, it's kind of different to similar movies as far as they're concerned anyway. That is a list of movies that are recommended by people that are kind of similar to whatever movie you're currently looking at. Okay, so there's a little bit of overlap, I suppose, between similar and recommended, but they're two different endpoints as far as Tmdb is concerned. There are also these, what I'm calling static endpoints within the movies area. So you can get a list of, if we take this one here, we're actually using this in the lab. Give me a list of upcoming movies. That's also paginated. That endpoint is paginated. You can get a list of the top rated movies of all time. So that would be a very simple page that you could add to your app. Just a page that, you know, there might be a hyperlink in the page header for top rated movies. Click on that and it shows you the 20 top rated movies. It's also paginated. So to get something like that working would be very straightforward. You wouldn't have to write any new components. You just have to have a new Tmdb API call, and you'd have a new page, but the page would have the exact same, it would use the exact same template as the home page. So for that and upcoming and new releases are now playing, sorry, again, there's somewhat of an overlap between now playing, upcoming, but as far as Tmdb is concerned, they're two different endpoints. So another example of a fairly straightforward page that you could add to your app would be a now playing page. And again, that's paginated, I think, but it would have the exact same structure as our Discover Movies page. So to get both of those working, you know, would require very little additional work on your part. But in terms of my grading spectrum, you'd be almost in the 40 to 50 grade band already. So, you know, it's not that difficult just to get a bare pass. I'm sure you're aiming for much higher than that, but you work your way to the top grade that you can do. So these might be simple things that you could get working straight away. And then based on your success, you start being more ambitious in your objectives. And this one as well is straightforward. We kind of have this one, I guess, from the labs, but certainly this one and this one you could achieve pretty much straight away. That's the movies. And if we flip over to Tmdb and go down to the movies part of the documentation, here we have it here. Don't like the way the page jumps, but there you go. And here you can see, look, there's loads of endpoints within the movies section, and you just click on them and it shows you how to use that particular endpoint. Okay, you usually don't need to know much more than what you have here. Okay, this is obviously a parameterized URL. It has query string, I think, or does it? It has some query string options. They're probably not. Actually, it doesn't really. It only needs the.
Sorry, Dermot.
Yes, sure.
Do we have 2 assignments for this module or just 1?
2.
2. Okay.
Yeah. The hand update for, did you see that? The hand update for this one is essentially kind of the end of semester. And the hand update for the second one will be just after or at the beginning of January. So time-wise, you know, I can appreciate now that as I'm talking my way through this, you may or you may not be saying, gosh, this is fairly heavy going, but you do have arguably, I think, quite an amount of time to try and work on it, essentially for you the rest of the semester to work on it. And I'm finished React from today. So you have all of the knowledge that you need to know, unless you're, unless you're getting into this kind of grade band, sorry, not that, unless you're getting into this kind of grade band here, you would need to do some other additional reading to get in there. I know I'm going on a lot now, but if I just go back again, I'm nearly there, I think, in terms of holding on to. So yeah, the movie stuff, look, you can see loads of possibilities there. And I would argue that you need to spend, I'd say, an hour, maybe even 2 hours, just browsing around this documentation before you ever start working on the actual assignment itself, so that you have a good sense of what's out there for you in terms of TMDB. And then based on that, then decide, plan out how you're going to, what features you're going to add on to your movies app. But definitely you would need to spend a minimum of 1 hour, and I would say 2 hours, just getting comfortable with what TMDB, just in terms of documentation, what it provides for you. The people part gives you lots of stuff related to actors, and that's probably what we're really interested in. You can get information on crew members as well, like directors and cameramen, etc., etc. So you can get details on a particular person. You can get all of the movies or TV series that person is related to. So, we're obviously thinking of maybe in our movies detail page, we could get the list of actors that took part in that movie. That's actually available to you from up here. Okay. Now we know the list of people that were linked to a movie. If we want to get a full bio of that person, well, we can use this one here. If we want to get a list of all of the movies that person is linked to, we can get it from here. TV series here that they're linked to. Static ones, if you want a list of the most popular actors of all time, that'll give it to you. Again, that's a fairly straightforward thing to get working. Trending information, certification. I really feel I'm going on too much. Or you could decide, I'm not interested in movies at all. I'm really more into the whole TV sort of stuff. And there's a whole set of endpoints related to TV-related information. Right, this is a bit of a marathon. Let's see. So I think I've kind of covered everything I can possibly cover. I don't know how many people are out there now, whether there's, I'll just give an opportunity for questions anyway, just in case there's anybody still listening to this. No, okay. So have a look at the spec. Remember now, you'll get the specification on Moodle. It's not available on the website. And as always, come to us with questions in the labs, preferably in the labs, I suppose, rather than in the lectures related to the assignment, which may only arise once you start getting stuck into this stuff. All right, that's it for now. So I'll talk to you again later in the week. Bye for now.
Thank you. Bye.